Hello everyone. Today we will tackle about the attitude of beds. So the attitude of beds refers to the three-dimensional orientation or positioning of a given geological feature such as a bed, a joint, a fold, and etc. Strike. So this is the picture below. When a bedding plane or a joint plane or a fold plane is cut by a horizontal plane, a line of intersection will be obtained at the surface. This direction is known as the strike, or the direction of the strike, or the line of the strike. Strike direction can obviously be represented as north 30 degree to west or as south 30 degree to west. Next is dip. The dip direction is the direction along which the inclination of the bedding plane occurs. The dip amount of the angle of inclination between the bedding plane and the horizontal plane is, for example, the beds are inclined at 30 degree to the horizontal and their dip may be expressed as south 60 degree to east. When the strike direction is north 30 degree to east or south 60 degree to western. So let us proceed to folds. The definition of a fold is may be defined as undulations or bends that are developed in the rocks of the Earth's crust. As a result of the stresses, these bends, called folds, may be developed in any type of rock. So there are the parts of a fold. First is limbs. Limbs are the sides of a fold. An individual fold will have two limbs. The first is axial plane. Axial plane is the imaginary plane bisecting between the two limbs of a fold, thus dividing the fold into two parts, as symmetrically as possible. Axial plane may be vertical, inclined, or even horizontal. Next is axis of the fold. The line of intersection of the axial plane with any bed of the fold is termed as the axis of the fold or fold axis. Next part of the fold is plane or pitch of the fold. When the fold axis is inclined, the angle which it makes with a horizontal, as measured in a vertical plane, is called the angle of plane. Next is crest and trough. Most of the folded rocks are composed of two general forms of folds. First is up-folded bends. Second, down-folded bends. The line running through the highest points in an up. Arc fold defines the crest, and corresponding line running through the lowest point of the same bed in a down. Arc fold is called the trough. So let's proceed the type of folds and their classification. First is anticline and syncline. When the beds are unfolded into an arc-like structure, it is called an anticline or an anticline fold. In such folds, the beds on either side are inclined away from the crest, and that is why the name anticline when the beds are down, folded into trough-like form. The structure is called a syncline. In this case, the beds on either side incline together towards the keel. The major classification of folds as anticlines and synclines, of which most of the folded rocks are composed of. The other classifications may be on the basis of position of axial plane, on the basis of degree of compression of the beds, on the basis of their mode of occurrence, on the basis of their position of fold axis, on the basis of their behavior with that and other miscellaneous folds. So the classification of folds on the basis of position of axial plane. Symmetrical folds. A symmetrical fold is that in which the axial plane is essentially vertical. The two limbs will have the same angle of dip in opposite directions. So asymmetrical folds, the fold in which the axial plane is not vertical but is inclined, is called an asymmetrical fold. Overturned folds. An overturned fold is a severely folded fold in which the axial plane gets so much inclined that the two limbs of the fold dip in the same general direction. The recumbent folds, these are extreme types of overturned folds, in which the axial plane acquires an almost horizontal position. The isoclinal folds. Isoclinal folds are those in which the limbs are dipping essentially in the same direction and at equal angles, so that their axial planes are essentially parallel folds, may be vertical, inclined, or even horizontal. The classification of folds on the basis of degree of compression of the beds. In the case of severe compression, the beds may get thinner at the limbs and thicker at the crest and troughs. The former type of folds, where the thickness of bed is the same throughout its fold layer, is called an open fold, and the latter one, where the thickness is more at trough and crest than the limbs, is called a closed fold. Next is the classification of folds on the basis of their mode of occurrence, anticlinorium and synclinorium folds. An anticlinorium fold is a large anticline which is farther thrown into smaller folds. An synclinorium fold is a large syncline which is farther thrown into smaller folds. Domes and basins. A dome is a special type of anticline in which the beds dip away from the central point in all directions. A basis is a special type of syncline in which the bed dip towards the central point. Classification of folds on the basis of the position of fold axis. Classification of folds on the basis of the position of fold axis. The fold axis may either be horizontal or may be inclined. When the fold axis is horizontal, it is called a non-plunging fold, and when the axis is inclined to the horizontal, it is called a plunging fold. The angle of inclination being called as the angle of the plunge. Classification of fold on the basis of their behavior with depth similar folds. The thickening of axial regions and thinning of the limbs, hence known as zone of rock flowage. Similar folds and parallel concentric. Parallel folds. Parallel folds are those in which the shape of the folds varies with depth, but the thickness of the folded bed layers remains more or the same. In such folds, the anticlines become sharp and sharper with depth, whereas the synclines become broad and broader with depth. Supratenuse folds. These folds exhibit thinning and thickening at the crest and the troughs. Other miscellaneous folds is a monocline. Monocline is a local warping in which the otherwise horizontal strata exhibit an abruptly steep inclination, and this inclination of a monocline may sometimes become enormous, so that a large difference of elevation between the strata on their side of the bend is introduced. Homocline. A homocline actually expresses a sequence of strata dipping in the same. Drag folds. Drag folds are the minor folds developed within the body of a weaker bed, enclosed between two stronger beds. Such as folds are developed due to the dragging effects. The weaker bed is called the incompetent bed, and the stronger beds are called the competent beds. Next is chevron folds. Mostly, the folds are rounded along their axial parts. However, sometimes when the axial parts are not rounded and remain pointed, and then they are called chevron folds. Let us proceed to the causes of folding. Tectonic causes of folding. Tectonic are those which are produced due to the forces operating within the Earth's crust, such as lateral compression caused by shrinkage and igneous intrusions and salt intrusions. Next is lateral compression. The stresses are developed within the Earth's crust due to shrinkage, resulting from the differential cooling of the initial hot molten earth. Igneous intrusions. Intrusions of magma from beneath may result in the folding of the overlying strata. The anticline folds may thus develop easily during the formation of laccoliths. Next is salt intrusions. The upward movement of salt bodies under pressure from beneath may also result in the arcing up the strata. The non-tectonic causes of folding. These include all those rock folding effects which are effective over the ground surface, resulting mainly under the influence of gravitational force. A few of these causes include: first is landsliding, second, creeping, third, differential compaction, fourth, isostatic setting, and five, subsidence into solution cavities, and lastly is glaciations. Next is landsliding. Landsliding may sometimes produce folding when large part of rock beds slide down the slopes and get buckled upon folded because of compression produced during their coming to rest. Engineering considerations involved in dealing with folded rocks. A civil engineer has to be very cautious while he is handling or excavating through the folded rocks because whenever the folds are disturbed, they release the stored energy and may damage the site in various ways. Moreover, folded rocks are generally highly fractured, particularly along the axial parts. These fractures not only make the rocks weak, but also act as channelways of the surface water to percolate through them. Fault terminology. Fault plane, the surface along which fractures occurs in the rock body, and there occurs a relative movement between the so formed rock parts, is termed as fault plane or fault surface. Fault trace or fault outcrop or fault line. This may be defined as the line of intersection of a fault plane with the ground surface. Dip and strike the fault. The inclination of the fault plane with the horizontal is called the dip of the fault. Direction perpendicular to the dip direction is nothing but the strike of the fault. Next is head. Head is the angle which the fault plane makes with its vertical. Hanging wall and foot wall. A fault plane separates the two blocks, and each block is known as a wall. Now, if the fault plane is inclined, then the block lying over the fault plane, through it may or may not be lying at a higher elevation than the other block, is called the handling wall. Whereas the block lying beneath and the side of the fault plane is called the foot wall. The up-through side and down-through side. Of the two blocks of a fault, the one which moves up with respect to the other is called the up-through side, and the one which moves down with respect to the other is called the down-through side. Throw. The total vertical displacement in a fault is known as the throw of the fault. Heave. The horizontal displacement in a fault is known as heave. Slip and its type. Slip of a fault is defined as the relative displacements of 2 points which were initially against each other. The classification of faults on the basis of the apparent movement and the fault blocks. Normal fault. A normal fault is the one in which the hanging wall has apparently moved down with respect to the foot wall. The fault planes of majority of normal faults dip more than 45 degrees. Next is the truss fault. A truss fault or a truss is one in which the hanging wall has apparently moved up with respect of the foot wall. Transparent fault or tear fault or transverse fault. It is that fault in which the blocks have moved against each other in an essentially horizontal direction. That fault in which the fault plane is vertical and the resulting movement of block is also in vertical direction is termed as vertical fault. Classification of faults based on the amount of the dip of the fault. High angle faults. These are those faults in which the fault plane dips steeply at angles more than 45 degrees. Low angle faults. These are those faults in which the fault plane dips gently at angles less than low angles faults. These are those faults in which the fault plane dips gently an angle less than 45 degrees. Classification of faults on the basis of the attitude of the fault. Strike fault. A strike fault is that in which the strike direction of the fault plane is essentially parallel to the strike direction of the adjacent beds. Deep fault. In deep fault, the strike of the fault plane is essentially normal to the strike of the adjacent beds. Oblique fault. An oblique or diagonal fault is that in which the fault plane strikes the bed, neither parallel nor normally, but strike obliquely or diagonally. The classification of faults based on the direction of the net slip of the fault. Deep slip faults. These are those faults in which the net slip in the direction of the dip of the fault. Strike slip fault. These are those faults in which the net slip is in direction of the strike of the fault. The classification of faults on the basis of their general pattern or mode of occurrence. Parallel faults. This term is used to express the occurrence of a number of faults having the same dip and strike. Radial faults. These comprise a group of faults that are arranged in a radial manner. the faults appear to be originating from a common point. Echelon faults. This term is used to express a group of faults that overlap one another. Steep faults. This term represents a combination of parallel faults in which the beds are thrown into step-like arrangement. Peripheral faults. When a given region, the faults are curved or acute, and they are arranged in a peripheral manner, enclosing a more or less circular area. Horse and a garben. A horse is a combination of two normal faults, occurring in such a fashion that their side blocks have been moved down with respect to the central block, resulting in the formation of a raised landmass. A garben is also a combination of two normal faults. Process of faulting. Faults are essentially the shear or sliding failures resulting from tensional compression or rotational stresses acting on the crustal rock's masses. Normal faults or gravity faults are assumed to have been formed under the influence of horizontal tension, whereby the crust would rupture or fail along vertical or nearly vertical fracture. Such as faults are therefore sometimes called as tension faults. Crust faults may be assumed to be originating from compressive stresses which may throw the rocks into folds, and this intensely fold the rocks getting fractured and faulted under shear. At a later date, these reverse faults are therefore sometimes called compressional faults. Next is the joints. Joints may be defined as cracks or fractures present in the body of a rock, along which there has been no relative movement as happened in the case of faults. These joints or cracks may be of small sizes extending only a few centimeters in length or may be extremely extensive. The open joints are those in which the blocks are separated or opened out for some small width in a direction at right angles for the fracture surface. In closed joints, however, there is no such separation. A rock is generally transversed profusely by various joints, but some of them may be more prominent and well developed, extending continuously for considerable lengths as compared to the others. Such prominent joints are called master joints or major joints. In the case of beds or faults, the inclination of a joint plane with the horizontal is called the dip of the joint. It is expressed as the angle in degrees and the direction with respect of north, south, east, and west. The line along which the joint plane meets the surface is called the strike of the joint, the strike direction being perpendicular to the dip direction. The geometrical classification of joints. Three types of joints is strike joints, dip joints, and oblique joints. Strike joints are those in which the strike of the joints is parallel to the strike of the beds. The dip joints are those in which the strike of the joints is perpendicular to the strike of the beds. And oblique joints are those in which the strike of the joints is neither parallel nor normal to the strike of the beds. The genetic classification of joints. The tension joints are those which are formed due to tensile forces or stresses produced in the rocks, either during their formation or after their formation. The important types of tension joints are columnar joints, mud cracks, sheeting joints, and lastly, moral joints. Columnar joints develop in igneous volcanic rocks, particularly basalts. These joints are hexagonal in plan and are produced in the body of the cooling magma due to the contraction caused by cooling. The mud cracks are also tension joints. Formed in a similar manner are columnar joints, but here the construction occurs due to the drying of the mud. Sheet joints. The horizontal joints develop in massive igneous rock, especially granites. These horizontal joints are closely spaced in the upper layers and become processively farther apart with depth. Moral joints. These are three sets of joints, mutually perpendicular, two sets of vertical joints, and one of set horizontal joints. to one another develop generally in igneous rocks, such as granite. The spacing between the joints is more or less equal, so that the rock is split into cubical blocks or moral. Shear joints. Shear joints are formed by the shearing stresses which tend to slide or actually slide one part of the rock against the other. Joints in different rocks. The joints are developed in three different types of rocks. First is joint in igneous rocks. Igneous rocks are joined to varying degrees depending upon the conditions under which the magma has cooled down for their formations. Joints in sedimentary rocks. Generally, two sets of joints more or less perpendicular to each other and also to the bedding of the rock are developed in sedimentary rocks. Joint in metamorphic rocks. These rocks are also sometimes heavily jointed, although regularly exhibited jointing patterns are rather poor. Geophysical methods. Seismic methods, electrical methods, gravitational methods, magnetic methods, radiometric methods, and geothermal methods. And that's all. Thank you for watching and thank you for listening. I hope you learn a lot about our topic, attitude of beds.